Hello, ladies and gentlemen, this is Ms. Skokin. We are in Chapter 4, Triangle Congruence, and this is Section 4.6, during which we're going to be talking about angle, side, angle, 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 side, and hypotenuse-leg theorems or postulates of congruence. Our objectives are to apply angle, side, angle, 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 side, and hypotenuse-leg to solve problems and to prove that triangles are congruent. We have new vocabulary, included side. Let's take a look at our warm-up questions. We have the instruction to use the diagram at the right for questions 1 and 2, and this is the diagram, this right triangle. The first question says, what are the sides AC and BC called? And they are these two sides, and those are called legs on a right triangle. The third side, side AB, is called the hypotenuse. The next question says, what is the side between angles A and C? And of course, we know that we name segments using the point names that they go between, so that is going to be segment AC. The next question says, given we have two triangles, triangle DEF and triangle GHI. If angle D is congruent to angle G and angle E is congruent to angle H, why is angle F congruent to angle 1? And this is, of course, because of the third angles theorem, which says if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent to each other. And here's our new vocabulary. An included side is the side between two consecutive angles in a polygon. So in this case, we have angle P, which is the blue angle. We have angle Q, which is the red angle. And we have this segment between them. The segment that goes between the two angles is called the included because it is adjacent to both of the angles P and Q. That brings us to our postulate, the angle side angle postulate of congruence, and it reads, if two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. Remember that we're trying to prove triangle congruence in several different ways, and this shows that we need to have the angle, the other angle, and the included side. So let's take a look at an example. We are going to skip example 1 and move right into example 2. Example 2, applying angle side angle congruence. We want to be able to determine if we can use angle side angle to prove the triangles are congruent, and then we're going to explain why or why not. Okay, let's take a look. We have two congruent angles here, and we have two congruent angles here. And if we want to be able to use the angle side angle, we have to have information about the segment between those two, or the included side, being congruent to each other. And we do not have that information. So that means the answer is no, because we would need to know that the included sides are congruent to each other. Instead of knowing that there's a congruent included side, we actually have this common side, which we know is used for both triangles, so it's congruent to itself, but that's not helpful for the angle side angle theorem. Now we've come to a now you try, so I'm going to ask you to pause the video, work it through, and then turn the video back on when you're ready to check your answer. Your answer may not look exactly like this answer, but as long as you addressed the two angles and the included side as being congruent to one another, then you've gotten the major idea. Let's move on to our next theorem. Theorem 4-6-2, the angle side angle theorem of congruence, says if two angles and a non-included side of one triangle are congruent to the corresponding angles and a non-included side of another triangle, then the triangles are congruent. So here we have two consecutive angles and a non-included side. that will still allow us to prove that the triangles are congruent. We're going to use an example, and we're going to work through using angle, angle, side to prove that two triangles are congruent. Okay, so we have a diagram, and we're going to start out by writing in all the information that's being given to us in the given statement. So it starts out by saying angle X is congruent to angle V. So we're going to put in our arc marks indicating that. Then we have angle YZW is congruent to angle YWZ. The last piece of information that we're given says that segment XY is congruent to segment VY. Now we've got everything. The one thing that I want to add to our diagram is what we're trying to prove. And we're trying to prove that triangle XYZ is congruent to triangle VYW. So as we look at the information on our diagram, we see some things that might be useful. For example, if we're trying to use angle, angle, side, let's go ahead and write in our first angle that we know about, and that is the one that was given to us at the very beginning, and that's angle X is congruent to angle V, and of course our reason for that is given. Now, we also have another piece of information about the other two angles that are congruent in our diagram, so let's write that in. And that reason is also given. Now, why that's useful is because even though those are not the angles that we actually need, those angles form linear pairs with the angles that we want. So we're going to document that angle YZW and angle YZX are supplementary. The reason for that, of course, is because they form a linear pair, and that is the definition, or one of the requirements of being a linear pair is that they have to be adjacent, which they are, but in addition to that, they have to be supplementary angles. Our next line is going to look very similar because this time we're looking at the other side, and angle YWZ and angle YWV are also supplementary, and our reasoning is going to be exactly the same for reason 4. Now we can write down the congruent statement for the angles that we really wanted. Angle YZX is congruent to angle YWV, and this is because angles that are supplementary to congruent angles are congruent. Last of all, we are ready to write down our side congruency statement, and that is that segment XY is congruent to segment VY, and that of course was given. So we're in great shape. That was our side. This was one of our angles, and then the other angle that we are using for our angle, angle, side was way up in statement number 1. So we can finally say that triangle XYZ is congruent to triangle VYW because of the angle, angle, side theorem of congruence. All right, I know proofs are not anybody's favorite thing to do, but it's a great exercise in really thinking about logic and knowing how to provide evidence for statements that we make. Let's move on to the next theorem. There are 4 theorems that can be used for right triangles to prove congruence, and they're listed here 1 through 4. The one that we're going to be looking at is the hypotenuse-leg theorem. The hypotenuse-leg theorem says, if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. So first of all, we need to verify that we have 2 right triangles. Then we need to check to see if the hypotenuses are congruent, and then we need to check and see if one leg is congruent. And that allows us to use HL, or hypotenuse-leg theorem, to prove 2 triangles are congruent. So in example 4, our instructions are determine if we can use the hypotenuse-leg congruence theorem to prove triangles are congruent. If not, tell what other information would be needed. So we take a look at our first diagram and we see that we've got congruent sides, we have a shared side, and then we have a right angle. So let's jot down what information we are gathering so far. To begin with, both triangles are right triangles. Because of the tick marks that were given to us, we know that the two hypotenuses are congruent. And because we have that shared side, we know that one leg is shared by the two triangles. So big picture overall, yes, we can use the HL theorem to prove congruence of these two triangles. In the diagram for question B, we see that we have three figures that make up a composite figure, a triangle on the left, a triangle on the right, and what is either a square or a rectangle in the middle. So first things first, we need to check and see if we have two right triangles, and we do. We can also see the tick mark that is included in the diagram, and that tells us that we have one pair of congruent legs. Last of all, we need to check and see if the hypotenuses are congruent, and although it looks like they might be, we do not have any information given to us about that, so we cannot make that assumption. That brings us to a now you try, so pause the video and work on this one. Turn the video back on when you're ready to check your answer. In short, with this example, we had two right triangles. We have two tick marks indicating congruent hypotenuses, and we have a shared leg, so we know that those are congruent. So all in all, yes, we can use the hypotenuse-leg theorem of congruence to prove these triangles are congruent to one another. And that does it for this lesson. So if you have questions on your homework problems, bring them to class and we'll discuss them. And I'll see you in class.